Have you ever stopped to think about speed? I mean, really think about it. We see it everywhere. A cheetah sprinting across the savannah, a fighter jet breaking the sound barrier, but there's a speed limit out there so absolute, so fundamental, that it governs the entire cosmos. It's not a law written by humans. It's a law written into the very fabric of reality itself. This isn't just a number. It's a barrier, a wall, and it whispers a secret about the universe that we are only just beginning to understand. It's the ultimate cosmic speed trap, and nothing, absolutely nothing, can break it. This is the story of light speed. Imagine a darkness so complete, so profound that it stretches for eternity. Then, in an instant, a single photon bursts forth. A tiny packet of energy, born from a star, begins a journey across the void. It travels at a speed so immense it's almost impossible to comprehend. This isn't just fast, it's the definition of fast. This cosmic speed limit, often just called c, is the universe's one true constant. Everything else changes. Time can slow down, space can bend, but the speed of light in a vacuum remains stubbornly, beautifully the same for every single observer, no matter how fast they are moving. It's a paradox that baffled the greatest minds for centuries. This universal constant is more than just a velocity. It's a boundary between the possible and the impossible. It's the gatekeeper of causality, ensuring that an effect can never happen before its cause. Think about it. If you could travel faster than light, you could theoretically arrive at a destination before you even left. You could watch events unfold in reverse. The universe, as we know it, would descend into chaos. So this speed limit isn't a cosmic killjoy, it's the very thing that holds the logical structure of our reality together, a silent guardian protecting the timeline of everything that has ever happened and ever will. But here's where the mystery deepens. Why this specific speed? Why not a little faster or a little slower? Why 299,792,458 meters per second? The universe didn't consult a committee, it just is. This number is woven into the DNA of space-time. It connects energy and mass in Einstein's famous equation, E equals mc squared. It dictates the expansion of the universe. So, what exactly is the speed of light? Let's break it down. On the surface, it's just a number, a very, very big number. It's approximately 186,282 miles per second. That's fast enough to circle the Earth more than 7 times in a single second. If you could travel at light speed, a trip to the moon would take a little over a second. The first real attempt to measure it came in the 17th century. Ole Romer. He was meticulously observing Jupiter's moons, especially Io. He noticed Io's eclipse timings changed over the year. When Earth moved away from Jupiter, eclipses happened later than predicted. When Earth moved toward Jupiter, they happened earlier. Romer deduced the delays were from the time light took to cross Earth's orbit. He realized he saw eclipses only after their light reached his telescope. From that, he made a rough calculation of light speed. It wasn't perfect by modern standards, but it was monumental. He proved light speed was not infinite. He put a number on it. In the 19th century, measurements improved. Hippolyte Fizeau built an ingenious experiment, an old sepia-toned diagram of Fizeau's cogwheel experiment. He used a rapidly rotating cogwheel. He shone a beam through the wheel's gaps. The beam bounced off a mirror kilometers away. He timed its return trip and adjusted wheel speed to catch the returning beam. James Clerk Maxwell worked on equations for electricity and magnetism. He wasn't initially thinking about light. When he unified the equations, they predicted an electromagnetic wave traveling at a specific speed. The calculated speed matched measurements closely. Maxwell realized light was an electromagnetic wave. That discovery unified 3 fields: electricity, magnetism, and optics. Light. It set the stage for Einstein's revolution. Here is where things get truly strange. The constancy of the speed of light forces the universe to do some very weird things to our notions of time and space. Albert Einstein was the first to fully grapple with this paradox. He imagined what it would be like to ride alongside a beam of light. If you could match its speed, the light wave should appear frozen next to you. But Maxwell's equations said this was impossible. Light always moves at c. This puzzle led Einstein to a startling conclusion. If CA is constant for everyone, something else must be flexible. That something is time itself. This is the core of special relativity. The faster you move through space, the slower you move through time relative to a stationary observer. This isn't a psychological trick, it's a physical reality. It's called time dilation. Imagine boarding a spaceship and traveling at 99% of light speed for what feels like 1 year to you. You would return to Earth to find many years have passed. Your clock would have slowed, your heartbeat would have slowed, your aging process would have slowed. The GPS in your phone has to account for this. Satellites orbiting Earth move very fast, so their internal clocks tick just a tiny bit slower than ours. GPS navigation would fail within minutes, errors of kilometers per day. It has become our ultimate ruler for measuring the vastness of the cosmos. The numbers become astronomical and honestly pretty meaningless. So astronomers invented a new unit of distance, one that leverages the universe's own constant, the light year. It's not a unit of time, but actually the distance light travels in 1 year. Light second to the moon, light minute to the sun, light year to Proxima Centauri. Every telescope is a time machine. The light hitting your eyes from Andromeda left before modern humans even existed. We're seeing a ghost from the distant past. The most distant galaxies we can observe are over 13 billion light-years away. We are seeing them as they were over 13 billion years ago, not long after the Big Bang. And that edge is called the observable universe, perhaps the most famous. Nothing with mass can ever reach the speed of light. As an object accelerates, its relativistic mass increases. As you get closer to C, your mass approaches infinity. Pushing an infinitely massive object any faster would require infinite energy. The universe simply doesn't have that energy. C is a cosmic finish line you can approach but never cross. For light itself, a massless photon, time does not exist. From a photon's view, emission from a distant star happens at the exact same moment as absorption by your eyeball. One of the most fundamental tests came from particle accelerators like the Large Hadron Collider at CERN. Tiny particles like protons are accelerated to incredible speeds. They are pushed with immense amounts of energy. But no matter how much energy is pumped in, they never quite reach it. Scientists have accelerated particles to 99.9999991% of the speed of light. At this speed, time for the particle slows down so dramatically that for every 1 second it experiences nearly 2 hours pass for us in the lab. Its mass also increases by thousands of times. In 1999, a team led by Lena Howe did the impossible. They passed a beam of light through a cloud of ultra-cold sodium atoms. They slowed the light from 300 million meters per second to 17 meters per second, about the speed of a bicycle. They didn't just slow the light down, they stopped it completely. They brought a pulse of light to a dead halt inside the atom cloud, stored its information, and then released it, sending it back on its way. It acts as a wall in our ability to travel. The dream of interstellar travel runs headfirst into this wall. Humanity's timescale is dwarfed by these cosmic distances. This wall also creates a horizon of knowledge. The universe is not static, it's expanding, and that expansion is accelerating. Very distant galaxies are being carried away by expanding space, faster than light. Over unimaginable timescales, more and more galaxies will cross this point of no return. The night sky of the far future will be emptier, lonelier. We may be in a brief, privileged era where we see a rich tapestry of galaxies. What lies beyond the wall? What secrets does the universe hold in those regions we can never see? Are there different laws of physics, different forms of matter and energy? We may never know. The story of light is an unfinished symphony, quantum entanglement, a bizarre connection between particles. Einstein called it spooky action at a distance. Future discoveries may come from places we least expect. Gravitational wave observatories listening to ripples in spacetime. The quest to understand light is the quest to understand the very structure of reality. In the end, the speed of light is so much more than a number. It is a character in the cosmic drama. It is a storyteller. It is a gatekeeper. It is a mystery. It connects us to the most distant galaxies. It confines us to our tiny corner of the cosmos. It paints a universe both elegantly simple in its rules and mind, bogglingly strange in its consequences. The journey to understand C is far from over. As we chase this beam of light, the universe still has plenty of secrets left to reveal.